your PCB designs, a common theme, and this is across a number of years this has been happening, you need some concept of track width. Now I've set up at the top here that you've got measurements up here, and the MIL refers to the American thousandths of an inch, which is an odd thing, but never mind. And what we can do is we can define the width of the tracks up here in nanometers, times 10 to the minus 9, we won't bother with that one. But we've got millimeters on here. I feel more comfortable in going for millimeters. Okay, so I've selected millimeters, and in this field here I can put whatever width I want in millimeters, say 2.5, something like that. Okay, so that's going to define my track width. What is a sensible track width? Depends what you're doing. We're going to export these over to China, and they're going to make some PCBs for us. We can probably reasonably go down to a fifth or even a tenth of a millimetre and still have that track survive the etching process. But why would you want to? Because the more copper you leave in place, the less has to go into the etching bath and the faster it can be made. You understand the process of how a printed circuit board is etched? Do you know what etching is? Okay, I'll do that in a little while, but let's just go through. Yeah, well, we'll dig some out for you. Just let me go through a few fundamentals on this first. So, most of you are in this position now, but many of you fail to understand what goes on as far as the track width is concerned. Some of you are rooted on the top rather than the bottom, but that's not the end of the world. One of the things that you can do here, which is quite useful, is you can go down into, so you've got all of these things on the bottom. Now, if you like, this section down the bottom here is to do with post-processing. It's after you've done the drawing and the routing and all that kind of stuff. You can make adjustments to that which you've already done. Now, inside here, in the nets, so click on nets, you've got lots of different tabs down the bottom here. But if you click on nets, I sometimes find it useful to drag up there a little bit so you can see it a bit better. So you've got here trace width, and it says 2 millimeters in here. Well, let's double click on that, and you'll notice that it's zoomed in to whatever track that is. So it's net name 0, but that's that one. If I double click on this one, it should zoom into the other one. No. Yes, it does. So double clicking on, always do it, unfortunately. But double clicking on it should highlight which track it is, and you can change the trace width. So let's go in here, and I'm going to change this particular one to 0.5 and press enter, and you'll see that that particular trace is now 0.5 millimetre wide. It's okay, we get away with 0.5 millimetre if we had to. But in general, the thicker the tracks you can make, the better it is, as long as you don't get overlaps. But the thicker the copper, the better the copper, because you leave more of the copper on the board, it's easier for the manufacturer to make, and what's the other reason? Current. Yeah. So you've got a nice big wide track, you're going to be able to pass lots of current to it. You're going to get less voltage drop across it, it's going to be far, far a better thing. So just to illustrate that point again, so I'll go to net name number 3, click on that, and I'll say 1.5 on that one, and press enter, and done it. Yes, it has done it, it's over here. So that's 1.5, that was 2 there. That's not quite so obvious at 1.5, so let's just go down to 1. Press enter. Someone said, what are they supposed to be? Well, it depends on the design. Sometimes you'll need to be down at 0.5 millimetre to be able to fit it in, and other times you'll need to be out at 5 millimetres, for example, the output stage of an audio amplifier or something like that. Remember how you changed the track of the board itself? So double click board outline. Lots of people seem to like doing this, and you can make your board. You can actually change the shape, but I won't show you how to do that now. You can have circles and hexagons and so on. So that's your board done. You know about the tools, View 3D, and there's my board. I'm not that proud of it because the layout's not very nice, and I could have got the components closer together. I've got the copper track. It's not showing the copper track, but the copper track is there, I can assure you. Okay, so I'm quite chuffed with that, reasonably chuffed with that. Okay, if I go back now, so what I'm going to do is I'm going to try and show you how to do, because at the moment you were doing manual routing, weren't you? Yeah? What we're going to try and show you now is auto routing. I'm just going to try and do this with Control Z, so I don't have to do too many steps back, but yes, it is going to let me, so that's good. So all I've really done is I've gone back to the beginning of my design, rather than export it straight back out of Multisim into Ultiboard. So that's how I would have come out of Multisim into Ultiboard. I've just got what's called the rat's nest, the wires interconnecting it like that. Now, on the, what I want to do is I want to select, because I'm using through-hole technology, I want to turn the top copper layer off, which I do by double-clicking on the arrow on the left-hand side there. I want to go down the bottom here. You can do that step up there, it's not particularly important, but I always do that as well. You go down to the bottom here where it says copper layers, and you'll see that it says routing, and at the moment it's prepared to make a 2-layer board. In other words, it's going to have copper on the top and copper on the bottom. Now you can have boards 2 layers, 3 layers, 4 layers, multiple layers. Generally it's quite tricky to manufacture anything beyond 2 layers inside a home workshop or in the bathroom or wherever you decide that you're going to make this stuff. We're going to stick with what's the absolute simplest, which is we're just going to have a single layer copper and it's going to be on the bottom. So if we go into here, remember where this is, so across the tab here, copper layers, and at the moment we're routing top and bottom. We don't want the top, so we're going to turn it off. Okay? So we've made that selection inside here. Inside the nets here, up the top here I've already selected millimetres, but what I want to do here is in the trace width, I want to go into the trace width. I've selected them all. You can do Control A or just click on where it says trace width, and I want all of my tracks to be 1.5 millimetres. So I'm going to go in here and do Control A to get all of them, and then finally go in here, get the 1.5. Okay, we've got Multisim over there, it doesn't matter.
Towards the presentation and just to the others in it.
Yeah, okay. So you'll see that we've done the trace width there. So now when we do the automatic routing, what we'll find is that all of those trace widths should be 1.5 millimetres. The other thing that we can do in here, and you haven't seen this yet, but if you make your traces too fat, what will happen is one trace can overlap with another one. And that's silly, because it just means that the auto router can't solve it. It will just say, I can't do that. So to avoid, or try to avoid overlap, what you can do is you can go in here to where it says trace clearance. Do Control A in there. And inside here I'm going to say 1 millimetre clearance. It seems very sensible to me. Notice that works first time that time. And so I've got a 1 millimetre trace clearance between all of the copper tracks I'm going to generate, and I've got a trace width of 1.5. I think I'm happy with most of that. So I'm going to go up to the top here where it says auto route, top of the screen. On auto route, I'm going to click start, zoom, round to error. Might something to do with that. Was that the clearance that we had? So we got an error inside there, and I think it's because of the trace clearance, so we're going to go down to 0.5. So it's just a question of where we put that control A, and we'll deal with that when we come round and see. Right, let's try and auto route that again. And you'll notice it's done it there. So the problem before was I had declared the tracks so wide that they were going to overlap with each other. So the auto router couldn't route it. So then what we did is we adjusted the clearance, so we then allowed 0.5 on the trace clearance between the components, and suddenly the auto router could route it for us. Now that's really useful, because what that means is you can drag your components. So if we go to Tools, 3D View, you can drag your components, not now, but when you were designing earlier, so that they look pretty on the top. And pretty printed circuit boards, more often than not, are nice circuit boards, good circuit boards. So it starts to become almost an art form, where you're going to put certain components in certain places, not for any other reason apart from aesthetics. You like it that way. Now doing that by hand is quite tedious, but doing it with an auto router, if it's possible to auto route on one layer, the machine will do it for you. Sometimes it's not, because what happens is you need one track to go through another track, which clearly isn't possible. So under those circumstances, what you will see is